Okay, I keep saying this. In math, anything you talk about, you're always going to have two things. You're going to have the symbols and numbers people use to explain something that's going on. So the numbers and the symbols are one area of math. They're important, but they're not the whole story. The other side of the story is the thing that they're trying to explain. Some sort of real-world actual thing that can tangibly exist, that's not just a symbol or a number, okay? So right here I'm going to show you exactly what Pythagoras found. I'm not an artist, so this won't be exact. I'm going to use a computer program to maybe show it a little bit more clearly afterwards, but I wanted to show you this from scratch. So take a triangle like this, and as a review, if we're using Pythagoras' theorem, it has to be a right triangle. It can't be a triangle that doesn't have a 90-degree angle, okay? So I'm going to use this right angle triangle, and I'm going to show you what he found. He just took one of these and he put squares on each edge. So let's say this edge here has, I don't know, a length of 4, okay? And then let's say this edge has a length of 3. And then, I think I'll leave this one blank. So let's say this one has an edge of 4. He drew a square on there. Now, I'm going to try and draw a square on here. Okay, so that's not exact, but this is supposed to be a square shape, okay? Now, if this is a square, then this side has to be the same as this side. So this side would be 4 as well. He went and calculated the area, and the area of a square is length times length. So you get an area of 16 for this square. Okay, let's move on to this square. Again, I'm going to make a square on the edge. So this has a side of 3. I'm going to make another side of 3 on the edge here. That's way off. Okay, there we go. If this is a side of 3, this is a side of 3 as well. We get an area of 9. Okay, right there's nothing amazing to be seen. What he did find that was quite interesting to him was that when he drew the area of the large square, even if he didn't know this side length, he noticed that the area of this square was the area of the other two squares combined. So in this case, he would have actually found the area here to be 25. What's special about that number? Well, 16 plus 9 gives us 25. He noticed that if you take this box and you put them together, they exactly match this box, okay? Remember though, that if you have the area of a square, you can take the square root of the area to get the side length. So I don't know this edge here. I don't know what this number is, but I have the area. If I take the square root of the area, I get this side length. So this side length here is the square root of 25, which happens to be 5. Okay? Small check in here. It's not that important what I'm saying right now, but remember that this has to be the longest side, right? So this has to be bigger than the other two. It's a nice check when you're working through these. Okay, so in a rough sense, this was his discovery, and it's an amazingly useful thing. It's a simple idea, but it really comes in handy in a lot of different areas, right? So just to summarize, he took the edges, he drew squares on those edges, okay? If you add up the areas of the squares of the legs, you get the area of the hypotenuse. If you have the area of the hypotenuse, you can take the square root to get that side length. If you have this side length, that's the exact power of Pythagoras' theorem. You can figure out this edge using math, okay? Now I'll show you the same thing, but on a computer. All right, you'll have to forgive me. You probably noticed in most of these videos that there is an annoying white spot on the board there. That's just the glare from the projector. It can't be helped. It doesn't fully get in the way of what we're trying to get at here. This is a really nice applet that's a little puzzle. clearly shows what I was talking about before. You'll notice that we're going to be able to take those areas of the legs and form the area of the square that sits on the hypotenuse. So I'll show you what I mean here. So notice I have the white square. I'm going to move the white square over. Takes up that spot in the middle. Okay. Now I'm going to move over these little pieces. They should add up. If I move this over, it doesn't fit there, but it does fit down here. If I take this piece, it doesn't fit here, but move it over there. Two more. What you'll notice is they do fit exactly. Okay? And this is a much clearer and easier to see version of what I was trying to show on the board. That is Pythagoras' theorem right there. And next, I'll show you the equation we use to explain exactly what you see there. All right, let's look at some problems. Triangle you have in front of you, this is a standard problem. The question is this a right triangle? No, you can't just eye it and say, oh yeah, it is. It looks like a right triangle. No, you have to prove it. And with the skills and tools you guys have at your disposal, you've only got one way to do this. And that is, you need to check using Pythagoras' theorem. If this is a right triangle, Pythagoras' theorem will hold. If Pythagoras' theorem doesn't hold, we know it can't be a right triangle. And you need to really remember that. If it's not a right triangle, you can't use Pythagoras' theorem. So I'm going to put a few things. We need to label this before we get started. I'm going to put in a little box in the corner, assuming that it's a right triangle. I don't know for sure. This should be a 90-degree angle for a right triangle. So I'm just going to put a little dotted box in the corner. The other thing that we need to do is label the hypotenuse. If you remember, the hypotenuse is the longest side and also is opposite the 90-degree angle. So this would be the hypotenuse on the edge here, okay? So you can label this if you would like. Just remember that this is very important, okay? So we said previously that if this is a right triangle, the areas formed on the edges should match up. So I'm going to use one of two methods that you'll see today. I'm just going to draw in some squares. Again, I am not an artist. These are not going to be pretty, but I think you'll get the general idea. So those are squares I've drawn in. Remember, a square has the same side lengths. So if this was 4 here, then this side has to be 4 here as well. If this side's 6, then this side has to be 6 as well. If this side was 8, then this side has to be 8 as well. The side lengths are only part of the picture. Remember that it was the areas that added up. So it was the areas of the legs, meaning the area of this box, plus the area of this box equals the area of the box on the hypotenuse. So let's find those areas. The area of a square is length times length. So this area is 4 times 4, which is 16. Okay. The area of this box is 36. And the area of this box here, 8 times 8, 64. So again, these boxes together will add up to the area of this box here, okay? If it's a right triangle. So let's check that out. Does 16 and 36 add to 64? That's the question. Well, if you actually add that up, you'll notice that 16 and 36 together gives you 52. 52 does not equal 64. So for this particular triangle, we know it's not a right triangle. Okay, we've just proven it too. So remember, if you're ever doing a problem, you need to show your work in some way. This is one way to do it. You just need to state that the areas don't add up. The areas formed on the legs don't add up to the area on the hypotenuse. It can't be a right triangle.